So now we'll move on in our review and talk about transformations in a function. So our original function here is x cubed. So if anything happens inside of that function, that's going to be horizontal, dilation, or translation. Anything outside that is going to be a vertical dilation or translation. In the first set of transformations here, there is nothing that happens inside of x cubed. That 2 is outside of it. So we're going to do that 2 first because it's multiplying. The 3 is also outside, and that's adding. So we'll do the multiplication first. That's outside, so that is a vertical dilation by 2, which means all the y values get doubled. Then there's an addition outside of the function, and that's also vertical. It's a translation, so it goes up or down. Since it's positive, it's going to shift this function up 3 units. In the second transformation, here's our function. There's nothing that happens inside of that function. We're going to do the plus 7 first. It's outside of the function, but it is inside the absolute value. So we're going to do that plus 7 first. That plus 7 is outside, so it's a vertical translation, which means it's going to shift the function up 7 units. Then what's going to happen with that absolute value, that's going to take all of our negative outputs and reflect them over the x-axis to become positive outputs. So in short, our negative y's become positive y's. So what this looks like is something like this. It's shifted up 7. So the graph would look about like that. But once I introduce that absolute value, it keeps all this up here, but all these negative outputs flip up this way and become positive outputs. In the last set of transformations, everything is inside the function because the cubed is attached to everything by these parentheses. So first we will do the multiplication. Multiplying inside of a function is a horizontal dilation by the reciprocal. So it's by 1/7, which means all of the x values get multiplied by 1/7. Then that minus 1 inside shifts the function right 1/7 of a unit. 1 divided by 7. So it shifts left 1/7 of a unit. Our next set of transformations, the original function here, the parent function, is the absolute value of x. So anything that happens inside the absolute value is horizontal. Anything outside the absolute value is vertical. Here we have multiplying by 2 inside of the original function. So that is a horizontal dilation by 1/2. And then outside there's a plus 6. That's a vertical translation, which means it moves up 6. In the next set of transformations, we've got a plus 3, and that is inside. That's a horizontal translation. And inside, we go by opposites, so that moves it left 3 units. And then we're multiplying by a negative, and since it's outside, that is vertical. It's a vertical reflection, or you could say it flips over the x-axis. So the whole function reflects over the x-axis. And then in the last set of transformations, there's a minus 2 inside the original function, which means it moves right 2 units. Then there's a minus 4 outside, which means it moves down 4 units. Identify the parent function. The square root of the opposite of x, the parent function, will be the square root of x. And what that looks like is the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So this is what the parent function looks like. but there is multiplying by a negative inside, which means a horizontal reflection or flip over a y-axis. So all these coordinates flip over the y-axis. So 0, 0 is going to stay where it is. And then we're going to move 1, 1 to negative 1, 1. 4, 2 will become negative 4, 2. And 9, 3 will become negative 9, 3. So that is what our final graph looks like. X minus 4 squared, that's a square function. Parent function is f of x equals x squared. 0 squared, 1 and negative 1 squared, 2 and negative 2 squared, and then 3 squared and negative 3 squared. So this is what the parent function looks like. And subtracting 4 inside of the function means it shifts right 4 units. So each coordinate needs to be moved 4 units to the right. So this is our final graph of the function when it's shifted 4 units to the right.